Alright, you are opening this video because you're having some trouble with using the rational zero test to find zeros of polynomials. We've spent a lot of time doing this in class, but it is kind of a tricky skill. So what I'm going to do is I'm going to write the complete linear factorization of this polynomial here. Let me just write it a little bigger so we can see it. 16x to the 6th minus 64x to the 4th minus 9x squared plus 36. Alright, generally speaking, what we could start doing here is factoring, and that would be a smart way to go about it. But for right now, let's just use the rational zero test because that's something that we need a little bit more practice with. So the way that I do the rational zero test is I first look at the constant term, which in this case is 36, and I list all of the factors of 36. So I've got plus or minus 1, plus or minus 36, plus or minus 2, plus or minus 18, plus or minus 3, plus or minus 12, plus or minus 4, plus or minus 9, plus or minus 6, and that should do the trick because plus or minus 6, there's no point in writing that again. So I'm going to take all of these and divide these by the factors of the leading coefficient, which in this case is 16. So I've got plus or minus 1, plus or minus 16, plus or minus 2, plus or minus 8, plus or minus 4. And then obviously plus or minus 4, but there's no point in writing that twice. Now, what I'm going to end up doing is I'm going to start using synthetic division, and I'm going to start with plus or minus 1. Alright, so I'm going to go ahead and start with 1. So I take 1 and I put it in what we've called Kevin. For some reason, Madison seemed to think that's totally the thing we should call it. So we have 16, negative 64. Oh, I'm sorry. Look at that rookie mistake. Since there's nothing in the x cubed place, I'm going to end up writing a 0 in its spot. So 0 goes here. Negative 64. And then, oh geez, that's in the 5th, and then the 4th, and then the 3rd is going to get a 0. You're going to have to forgive me, it's 9:44 on a Saturday morning. And I'm just going to check and see, and you can clearly tell by my lines that it's very early. I'll go ahead and start bringing this down. So I bring the 16 down, multiply that by 1, I get 16, 16, 16, simple enough so far. Negative 48, negative 48, negative 48, negative 48, negative 57. I think at this stage in the game it's pretty obvious that I'm not going to end up getting a 36 here, so I know 1 is not the winner. And me personally, I like to try out a whole bunch of integers first, and since 1 looked like it wasn't going to end up working out, I feel pretty confident 36 won't either. So I'm going to go ahead and try plus or minus 2. Okay, so let's just try 2. And, you know, in actual good practice, what you would want to do is try minus 1. But I don't want to make a video that's 6 years long, so I'm just going to go ahead and try 2. So I get 16, 0, negative 64, 0, negative 9, 0, 36. Now, as a note, this is about a degree larger than the biggest polynomial I will expect you to be able to do on the test. So, don't freak out if this seems huge, because this is kind of just a party trick at this point. So then, 2, 32, negative 32. Am I doing this right? Nope. God bless them, folks. It's way too early for this. Blah. It's alright though. It's alright. Your math teacher's not terribly bright. So then the 32 goes here. 32 flops down here. 64. So then that becomes a 0. 0. 0. 0. Negative 9. Negative 9 times 2 is negative 18. Negative 18. Negative 36. Alright, cool. So we have a winner. So now what I know is this is the coefficient for the x to the 5th term. So now I know that x minus 2 is a factor. Okay, because I know that 2 is a root, therefore x minus 2 is its associated factor. So now I've got x minus 2. And what's left after that, and I'm going to do this in a different color, because this is now the polynomial we're trying to break down. Since it was to the 5th, that 16 goes in front, or I'm sorry, since it was to the 6th, that 16 goes in front of x to the 5th, plus 32 x to the 4th, and then 0x to the 3rd, 0x to the 2nd, minus 9x squared. I'm sorry, hold on. 4th, 3rd, 2nd, 1st, negative 9, geez, negative 9x minus 18. Alright, so now I'm going to completely disregard this first polynomial. I totally don't need this thing anymore. Because I've gotten a factor out of it, now I'm going to really hone in on this thing here. Okay. And now from here, what I'm going to try and do is factor this thing. I'm always looking to factor, because this thing can become really convoluted if I just keep using the rational zero test. So use the rational zero test to get a 0 out of it, and then you're going to try and factor it. Alright, so I'm just going to go ahead and try this, see if I can't break this up. And there's 4 terms, so I'm definitely going to try grouping. Boom, boom. 16x to the 5th, 32x to the 4th, that's 16x to the 4th. And what I end up with is x plus 2. And then I'm going to pull a negative 9 out of this thing, and I get x plus 2. Alright, well that's great. So now what I end up with is this group here. 16x to the 4th minus 9 x plus 2. And now I'm just going to go ahead and drag this first factor down here just so that I can always kind of keep it available to me, because I did all that work to find it. And now what I'm going to need to do is break this thing down. And this actually, 16 is a perfect square, x to the 4th is a perfect square, and 9 is a perfect square. I can break this thing down really nicely to 4x squared minus 3 and 4x squared plus 3. Okay, and I'm just going to go ahead and remember these later. I'm not going to write them out every step just for efficiency's sake, and I don't want to make a video that's 6 years long. So what I ended up with in my last screenshot, I had 4x squared plus 3 and 4x squared minus 3. Now from here, I'm just going to go ahead and use the square root method to work this out. So 4x squared minus 3 equals 0. I'm going to go ahead and add 3 to both sides. And I get 4x squared equals 3. Divide both sides by 4. And I get x squared is equal to 3/4. So now I take the square root of both sides, and you guys need to remember, oh god. There we go. So now I'm going to take the square root of both sides. That's slightly better. And I get x is equal to plus or minus the square root, geez, of 3 over 4, which I know simplifies to x is equal to plus or minus the square root of 3 over 2. Alright, so now I know two more factors. So now I've got x minus the square root of 3 over 2 and x plus the square root of 3 over 2. Now the associated factors are obviously opposite. The plus gives me this factor and the minus gives me this factor. And so I'm going to do the same type of thing here. I got 4x squared plus 3 is equal to 0, which I'm going to basically do the same steps here, except instead of adding 3, I'm going to subtract 3. So now, after I do all that, I end up with x squared is equal to negative 3 over 4, which means I now have x is plus or minus the square root of negative 3 over 4, which since I've got the square root of a negative, I know I have x is equal to plus or minus I square root of 3 over 2. And so these factors are going to end up being x plus I square root of 3 over 2 and x minus I square root of 3 over 2. Okay, and these factors come from, this one comes from the minus, and this one comes from the plus. Alright, so look. Just an x, just an x, just an x, just an x. So my final factorization from the last page, I found x was one of the factors was x plus 2, the other factor was x minus 2. And then these two factors here, I had x minus the square root of 3 over 2, x plus the square root of 3 over 2, and now I tack these factors on here. I had x plus the I square root of 3 over 2 and x minus I the square root of 3 over 2, and I'm done. Just some quick tips. Okay, just some quick tips for problems like this, because you're looking for efficiency here. The first one, okay, and this is actually really the biggest one, choose rational zeros carefully. Look for a sign change. If you find a sign change, then that means there's a zero somewhere in those, somewhere in between those x values. Now that doesn't necessarily mean it has to be rational, but it can totally be there. And the second of which, I think you should always look for factorization. Or we should always look for factoring. Okay? Always look for, if there's 4 terms, look for grouping. If you come down to 3 terms, see if you can't break it up into a trinomial. And if you follow those steps, I think that you should be able to get these problems done really efficiently, and I don't think you should have any problems. I hope you enjoy the rest of the problems that I left you. I know that they are quite pleasurable if you enjoy long spells of algebra, and I will see you next week. Enjoy it.